Okay, let's get started. Here we have 2017, code 3060, paper 1. Let's get started. Bismillah. Here, here we have a triangle, the Jacobs-Shell triangle, which has ABC. AB, which we have here, AB 4 centimeter, BC 7 centimeter, and beside them an angle 120, okay, which is angle B. Given that the cosine 60 equal half, why he give you cosine 60, find the exact length of AC, just to help you because it's non-calc paper. We want to help you. This remember that is this is the 60 degree on the unit circle, and actually this is the 120. They have the same value in the cosine. The cosine is the x-axis here, the value of the x-axis, but they have it the same. So the cosine 120 will be negative because it is an x-axis. It will be negative half because the x-axis here is negative, okay? X-axis here is negative. So just to give you this 460. Okay, let's see. Here we are going to apply for the cosine rule, which say, what's the cosine rule say? Say that is the AC will equal to the first one squared, 4 squared, plus the second squared, 7 squared, minus, again, 2 multiplied by the first, 4 multiplied by the second, 7 multiplied by the cosine 120, which will be negative half. Okay, and here for sure we're going to flip the sign to positive just because we have here negative and negative. Okay, so let's get started. So it is 16, 49, and here minus 2 times 4, 8, 8 times 7, 56, 56 half of it, which is 28, and negative and negative positive, so it is plus 28. All of these numbers under the root. Okay, so it will be the AC will be under the root, so this will be equal to root 93, and keep it as it is root. It's a non-calc paper. Okay, and now we did it. Let's see the next. Okay, number 2. Here we have A and B probability. Or eventuals, that's A equal half, union equals 0.9, and B from A equals 0.6. Find the intersection. Actually, here we have the formula sheet, and you have the rule to say that if you have the intersection, if you want the intersection here, I told you here that if you need to apply for the intersection, if you need the first intersect the second, you have to write like A intersect B. It will give us to the first one probability of A multiplied by the probability of B from A. Okay, let's see it, how we can solve it here. And here you can say this, here we have we're going just to apply for the numbers here. So we get it, he needs the intersect. So he needed the intersect. So the A here is equal to half, and probability of B from A is 0.6. And so 5 times 6 is 30. So the final answer is 0.3. And how we get the probability of B? Actually, there is another rule who say that is the union, the first union second, it will be equal to the first A plus b minus the intersect. I always said that he always get question I depend on I. So put full focus in question I because it's the rest of the questions depend on it. Okay, so here is minus the intersection, which is A intersect B. So what we do, we're going to just apply for this and say that is the union, which equal to 0.9 will be equal to the first, which is 0.5 plus b, and minus intersect, which is 0.3. So here it is solved here. So here 0.9, 0.9 will be equal to 0.2 plus the probability of B, and that is this question here, probability of B. Okay, and so minus 0.2 minus 0.2, so probability of B will be equal 0.7, and included it. There's no more questions in here. Yeah, we get it. Let's see question number 3. The function is defined for 3 and 6. And question number 3. Here is the function. The function f is defined for 3. So x is between 3 and 6 here. So what you want, fx equal x minus 3 squared plus 1. The diagram shows a sketch. Okay, explain why f has an inverse. The same question, why f is a function, because each value of x has special value or has unique value of y, has unique value of y. So this is the same, like why f is a function. The same question, okay, but he get it with a different way. So each value here of x, so the 3 has different value, the 4 has different value, the 5 has different value. Each point, no one has 2 points like the scatter. Okay. Here, you want to get the inverse. We did this. So I'm going to move to the next. Okay. Here you want f dash. Okay, and if you want f dash, we have to flip. We have to just flip the x and y. So, and instead of fx, we're going to put fx, which is equal to y. We're going to say x equal to y minus 2 minus 3 squared, y minus 3 squared plus 1. I just changed the places of x and y just to get the inverse of it. Just to get the inverse here, I have to put in instead of fx over x, and then put in instead of x, y. That's what I do just to get the inverse of the function. Okay, so here I'm going to get the value, the subject of y in terms of y. Okay, let's get started. We're going to say that's here the x will be minus 1. So minus 1, and here minus 1 ik. So equal to 1 minus 3 squared. So I'm gonna get the root of both sides. When we get the root of here, we kick it with this, so it's equal to y minus 3, and then make plus 3, and here plus 3. So actually here the final answer will be x minus y under minus 1 under the root plus 3, which equal to the inverse of the inverse function of the inverse of fx, or the inverse of y. Okay, we did it. Let's see the next. Okay, in this question in III, he asked about the range, and the range is the y-axis of the inverse. The y-axis of the inverse, actually, it will be the x-axis of the fx. We just flip the x we get the y in terms of x in the inverse. So what we do here to get the range, it is the same like the range, which is the y-axis. It's same like the x-axis, but in the f of x, not in the original, okay, not the inverse. So let's see where the f of here, the x, he give it to you that is in between 3 and 6, and also the range will be between y will be between 3 and 6 in the inverse function. Okay, and that is the range. The range he asked about the y axis. Okay, and I think question 3 is done. Okay, that is the range. Okay, and then we did the range, we did the inverse, and we say why this has an inverse, or why f is actually a function. Okay, let's see question 4. Okay, question number 4 here. He asks you a matrix to get a 2 by 2 multiplied by 2 by 3. So actually I'm going to apply for this, just to multiply this by the row multiplied by the columns. So this row multiply by the column, and so on. Each column. Okay, let's get started. So the first one, 5 multiplied by 5. With 2 of them multiplied by 5, which is 10, plus negative 3 multiplied by 2, which is 6. So negative 6. So it will be 10 minus 6. Next here, 2 multiplied by 1, which is 2. Negative 3 multiplied by 0. Negative 3 multiplied by 0, which is plus 0. The third column here, 2 multiplied by 2, which is 4. And 2 multiplied by negative 3 multiplied by negative 1, which is positive 3. Okay, and the next, we're going to change here and get the second row step by step. Okay, so here, one and one, and here we're going to apply for each column alone, 5 2 and 1 1, 1 0 and 2 1. Okay, let's get started. 1 multiplied by 5, the same is 5, plus here 2. Next here it would be 6. 1 multiplied by 1, which is 1, and 1 multiplied by 0, which is 0. I'm going to write them as it is 2 minus 1, because both are 1. So let's write the final answer here. The final answer, 10 minus 6, which equal to 4, then 2, then 7, then 7, then 1 and 1, and we're going to close it with a matrix sign, and we did it. Okay, a to the inverse. Okay, how we get it, the inverse of it? First of all, we have two steps. First step, we have to get the determinant of the a, which is equal to the determinant here will be equal to, as we are going to say, 2 times 1, 2 times 1 minus negative 3 times 1, which is negative 3. So 2 times 1 minus negative 3 multiplied by 1. So it's equal to 2 plus 3, which equal to 5. Then we're going to flip it. We're going to flip it in the following also. Then the second step is easier than the first. We are going to switch the A and D. That is we call it A. We call it here A. So here is A, and here is B, and here is C, and here is D. Actually, we're going to switch A and D, so it will be 1 and 2 and negative sign for the B and C. So this negative would be positive 3, and the 1 would be negative 1, and we did it. That is the inverse of it. Okay, let's see the next. Okay, question 5, derivative, first derivative and second derivative. Here we have y equals 6x minus 3 over x squared plus 2. We don't have to leave it like this. We have to rewrite it before we have the first derivative or the differentiation. So the first, we are going to say y equal to 6x minus 3x to the Okay, again, question number 6. Yeah, question number 5. Again, here he needs the derivative of y equals 6x minus 3 over x squared plus 1. And all what we do, we are going to rewrite the derivative. So we're going to rewrite the equation first before we get the first derivative or the differentiation of it. So it is 6x minus 3x, not squared, but negative squared, plus 1, because we get it up from the denominator up with negative. Okay, and here now we are ready to make the first derivative here. So here in this step, we are going to get the value of the derivative here. So we're going to say that dy over dx, dy over dx will be equal to 6, this power 1 minus, which we are going to change it to positive because multiplied by negative, so let's change to positive. 2 times 3, which is 6, minus 1 x power negative 3. And that's all. We get it. So final answer would be 6 plus 6 over cubic root of x. Write it like this or like this. We did it. The next here, we need the second derivative. So we're going to take this one and we are going to get the second derivative. 6 doesn't have derivative of it. Nothing, but I'm not going to take it. So dy second over dx will be minus 3 multiplied by 6, which will be negative. Let's write it here because it's only one step. Negative 18x minus 3. We're going to get it minus 1. So it will be negative 4. And we did it. Let's see the next. Okay, question 6. Vectors. Here we have vector A and B are given by A 6 and negative 8 and B 4 and 2. The angle between two vectors A and B is theta. Okay, use scalar product to find the exact value of cosine theta. Okay, we say that is the cosine rule. Okay, remember it. Cosine theta will be equal to vector A scalar product multiplied by B dividing by the magnitude of both A and B, multiplying each other, the magnitude of A multiplying the magnitude of B. And now we're going to apply for this rule. How we get it, how we get here the scalar product for A and B. So here we have to make 6 times 4, 6 times 4, which is 24, minus negative 8. Actually, it's plus, but negative 8 plus 8 multiplied by 2, which is 16. So it would be minus 16. Yeah. Dividing by the magnitude. Okay, let's work out the magnitude here. The magnitude will be 6 squared plus 8 squared for A, magnitude A. It will be 6 squared plus 8 squared under the root. 6 squared, which is 36, plus 64, which is root 100. Okay, and here we have to get the magnitude of B, and magnitude of B will be 8 square, 4 square, the root of 4 square plus 2 square. Okay, and here it will be 16 plus 4, which is root 20. So here will be multiplied by root 20. And actually root 24 minus 16, which equal to 8, dividing by root 100, which equal to 10, root 20. Okay, don't leave the root like this. And he asks you in the form of k root 5, root 5. So we need to apply for root 5. So the root 20 will be equal root 4 multiplied by 4 times what? Equal 20, guys. So it's root 4 multiplied by root 5. And root 4 equal 2 multiplied by, so it is 2 root 5. So root 20 will be equal to root 5. So the k here, yeah, so I'm going to say it's equal to last simplify, okay? So here it will be 8 over 20 root 5. From where I get 20, I multiply the 10 by the 2 root 5. Then I kick the root 20. And here I'm going to simplify 8 divided by 4, which equal to 2, yes, but to 2 over 20 divided by 4, which equal to 5 root 5. So actually it is 2 over 5 root 5. And actually, we're not going to leave it like this. We're going to kick the root in the denominator just to leave it in the same that he wanted, okay? Here he wanted in a form. Don't forget the form, not to lose a mark. So here, I'm going to simplify. I'm going to simplify this root. Yeah, I'm going to make it here. So the answer was 2 over 5 root 5. I'm going to multiply both numerator and denominator by root 5 over root 5. So here will be root 5 over root 5. So now it's in the numerator 2 root 5, denominator 5 times 5, which is over 25. Final answer. It has a 5 marks and we did it. Okay, so 2 root 5 over 25. And that is the K, which is 2 out of 25, and root 5 is root 5 that we need. Okay, let's see the next. Okay, question number 6. Here ask it for the expansion, my favorite. Okay, let's see it. Here we have the first term, 2x. So we make it 2x to the power. Don't forget that here we have the 2 also to the power of 4 plus 2x. You don't have to leave a big space. So, yeah. The first number is unique. 2x to the power of 3. The first and the last are unique. So here 2x to the power of 2. Then 2x to the power of 1. Look, we did it. Okay, so next. The second term, which is positive. Make sure that is a positive sign. Make sure that you have a positive sign, so they are all plus. So the b to the power of 1, b to the power of 2, then b to the power of 3, and the last one, which is unique like the first, b to the power of 4. Okay, Pascal, here the 4 multiplied by 4. Okay, multiplied by 4, multiplied the second one by 6, third one by 4. Okay, let's write it here. And the last one is unique. Okay. He need here find the coefficient of the cubic x equal 40x. So that is the cubic x. Where is the cubic x yet? Here the cubic x. This is the cubic b. Okay, so let's see it, how we did it. So 2 to the power of 3. Okay, make sure that you cubic the 2, which equal to 2 to the power of 3, which equal to, yeah, 2 to the power of 3, which equal to 8 x cubic multiply by b multiply by 4. So 4 times 8 equals 32. 4 times 8 equal to 32. So the total is 32b equal to 48 because he asked you that is the coefficient of the cubic. So we just kick the cubic out, okay? And multiply all the numbers. 2 to the power of 3 is 8 times 4, 32 times b is 32. So now it's equal to 48. So the b, I think it's equal to 1.5, which is 48 dividing 32. Yeah, exactly equal to 1.5 or 3 out of 2, as you wish. Okay, and we did it. Let's see the next. Okay, he asked you in this question. He asked you use, yeah, okay, use appropriate coefficient from Pascal triangle to find the constant term. Okay, let's find the constant term in the expansion 2x. Okay, another one, another expansion, which is my favorite. Okay, let's do it. Okay, 2x to the power of 6. Remember, that's minus, okay? So minus because the first one is positive, then negative. Okay, minus 2x all to the power of 5. Don't forget to put the bracket, just to put the 2 to the power, okay? Plus 2x to the power of 4, then 2x to the power, here is 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus the power of 3 plus 2x to the power of 2, then minus 2x. Okay, to the power of 1 and done. Let's see the second term, which is 1 over x. Okay, so 1 over x to the power 1. 1 over x all to the power 2. The power 2. 1 over x all to the power 3. 1 over x to the power 4. We already wrote the sign. 1 over x to the power 5. And the last one will be the unique, like the first, plus 1 over x to the power 6. Remember, the first one is to the power 6 and the last one is to the power 6. Okay, let's see. So we need it. Here we need to get the constant term. Okay, let's move to Pascal, power 6. Let's see power 6, what we have inside it. Here, he have draw it to you. If you haven't drawn it to you, so please draw it for yourself. Not to put a lot of numbers inside your expansion, just make you confused, you know that? Okay, so copy 6, then 15, the second, then 20. Here is 20. Here is the power 2 is 15, and the last one 6, and the last one 1, the unique one. Okay. Remember, always I depend on question I. So here was the coefficient of the x cubic, and now we're going to get this number, the constant term here, 2 to the power of 3 times 20, which is 2 to the power of 3, which is 8. 8 here, and 8 here, to be 2 to the power of 3, which is 8 multiplied by 20, which equal to, don't forget, here we have a negative sign. It's not to miss it, okay? Equal negative 160, and we did it. Let's see the next. Okay, question number 8, sets. And actually sets, he tests your focus. So put your full focus in this question. So here he gave you a gem that have a 200 inside it. So this gem will be have, draw your own one just to can remark it easily. Okay. So here it has a 200 inside it. The total, okay? Each member either G or ordinary member or SC. So junior or senior or ordinary. So we have G for junior, and we have S for senior, and O for ordinary. 94 are male, so we also have male with for M. So this, I think, for the M. So he keep, this is for the male, and we're going to draw our own set for is equal to 94, okay? And the 51 members have junior membership, and those 29 females. So from the junior are total of 51. So we also are going to make it in our schedule for the junior. They are 51, which they have 29 females. So we're going to write 29F, 29F, and for sure the male will be the rest. So the M will be 22 for the male, okay, and 22 for the male. So from here we're going to take 22 as for the senior, okay. 18 of the male members have senior membership. So in the senior 18, we're going to take another 18 as for junior and another 18 for senior, okay. This is J, junior. Okay, so here in the senior, I'm going to, in my set, before I write anything in his set, I'm going to say that here we have 18 members minus 18, which they are in for the male. Okay, we don't know the total of the senior yet. 45 of the female members have ordinary membership. So I think there is no ordinary here in the circles, but I'm going to leave them outside. Maybe they are outside. Okay, so sets M, G, and S are defined as male, junior, and senior. Use this info to complete the Venn. Okay, here we have a common with the male and the junior. Male and junior with M and G with the R22. And male and S with the R18. If we subtract from the 94 the 40, this it will give us 54 remainder, just male, not senior, not junior. Okay, and here what we have in the rest of the junior, which are total 50, total 51, then we're going to take the 29 females from them, the 29 female for the junior, not ordinary, okay, 29 females. And for the senior here, he give us just, we have 18, but they have a total of 200. So we can add all of this up just to get the rest of the senior. We have a total male. We have a total male for, don't forget when we add it up, we just take the whole male, which is the whole male, which is 94, okay. 94 minus the 29 minus the 45. So what we do, we are going to say this 200, we're going to subtract from them this 200. First of all, 90 from the 200, which is 110, 106, minus 94, which is 106. 106, you're going to take from them 40, which is 60, 61. 61, then you're going to take 30, which is 29, take 30, then add 1, which is 32, so the remainder here will be 32, and did it. Okay, let's see the next. Here he asked for the probability for one of the 200 members is selected random, and the probability that CR has ordinary. Remember this ordinary word we have been saying for the ordinary. Remember the ordinary we have been saying for the female. It's like the female with the um, ordinary members, maybe outside the senior, outside the junior, which are 54 from the male and 45 from the female. They are ordinary, not senior, not junior. Okay. Actually, this question need a translator. Okay, but anyway, that is the ordinary. The last part here to find the probability here. So the probability would be equal to 45 from the females plus the 54 from the male, which equal to 99 out of the total. The probability selected has ordinary membership from the total, so 99 over 200. And the probability is the only fraction that's allowed for you to keep it as it is in the exam without losing any mark. Okay, let's see the next. Okay, question number 9 here is drag. Prove that for sine not equal, sine theta not equal to 0, 1 plus cosine theta multiplied by cosecant theta minus cot theta equal to sine. Okay, first of all, we are going to, this is the flip. Remember, this is the sine, the flip 1 over equal to 1 over cosecant. Okay, 1 over cosecant. So we're going to solve it here. So we're going to keep it as it is, 1 plus 1 here, plus cosine. Okay, multiply by cosecant. I'm going to change it because it's a flip, so it is 1 over sine, 1 over sine minus cot. Okay, I'm going to multiply back normal way. So 1, I'm taking first of all the 1 multiplied by both. So I'm going to show this one multiplied by 1 over sine, and so when I say 1 here, so multiply by 1 over sine, so it is 1 over sine. Easy. The same 1 multiplied by negative cot, so it is negative cot. Okay, then next I'm going to say the cosine, positive cosine. I'm going to take it. The positive cosine multiplied by the 1 over sine, which equal to plus cosine over sine. Okay, and here cosine multiplied by cot, it's negative cosine cot. And for sure, all of this have theta, theta, theta beside it. Okay, sine theta, cot theta, and so on. Okay, yeah. And here I'm going to change. Remember, sine, cot theta. Okay. Here I'm going to change this cosine over sine. Remember that the tan, tan have a flip of 1 over cot, is right? And the tan equal sine over cosine, is it right? Sine over cosine. And the flip of it is cosine over sine. So the cot is equal to cosine over sine. So I'm going to say that is this is cot, positive cot. I'm going to cancel it with the negative cot. So the remainder now here is the 1 over sine theta minus cosine cot theta. Cosine theta cot theta. Okay, so now and for the cosine and multiply by cot. Remember again that cot equal cosine over sine. Multiply by cosine. So it's equal to cosine square equal to negative cosine square theta over sine. Is it right? Over sine. And now we have a common denominator, which is 1 over sine and cosine square over sine. So we can say it's equal to 1 minus cosine square, my favorite rule, the squared rule, the square sine plus the square cosine equal to 1, okay? So 1 minus cosine, remember this rule, always remember this rule, which is sine square plus cosine square for theta or x or y or whatever the angle is, square equal to 1. So when I say 1 minus sine equal cosine, is it right? And 1, of course, squared, okay? Don't forget the squared. And 1 minus cosine equal to sine. Okay, and now we're going to say that 1 minus cosine square equal to sine square, is right? According to our favorite rule, sine square theta over sine square over sine, just only sine theta. So we're going to kick the denominator by the square, which equal to theta, and we did it. Yeah. And let's see the next. Okay, in this question, he asks you to find the value of this. Directly sine and cosine deal it with, like, the flip, cosine square plus sine square equal 1. Everything, just the flip rules. And the flip rules, I mean 1 over cosine, 1 over sine, which is cot, cosine, and so on. Then solve it. Okay, let's get started. Here we have, I will take the numerator first, okay? Then I'm going to move to the denominator. Okay. Let's take it step by step. The first step here, I'm going to say, here I'm going to say that's 1 plus cosine. Away from this pi 5, keep it away because you are all as if you don't see it, okay? Theta, I like theta, okay? So it is 1 plus cosine, okay? Multiply by the second. Cosecant is the flip of 1 over sine. Is it right? The same like the previous question. Okay, cot, keep it cot as it is. Okay, minus cot. Okay, and now we're going to multiply normal brackets, okay? I'm going to say this is the first bracket. So 1 from this bracket multiply by those equal the same. So it's equal to the same. Here is number 2. Yeah. So I'm going to say it is 1 over sine minus cot, the same. Okay, step by step. Remember that pi over 5 will make you confused, so make it like theta. Make it theta, okay? Okay, let's say here in the beginning, let pi over 5 equals theta. Okay, then the second here, which is cosine multiply by 1 over sine, which is cosine over sine. Okay, sine will be positive, so cosine over sine. Then cosine multiplied by negative cot, which is negative. Same. Remember the flip. The tan equals sine over cosine and cot equal cosine over sine. So I need to kick the positive with the negative theta, of course. Okay. Then remainder here. Here we have step number 3. Here we have 1 over sine minus cot. Okay. Then I'm going to change this cot to cosine over sine. So 1 over, remain this 1 over sine, and minus cot theta plus. Okay. So 1 over sine minus cot, I will make it cosine over sine. Cosine over sine. Okay. Theta, theta, theta. Okay. And now we have a common denominator here. So we can say that's 1 minus cosine, which equal to 1 minus cosine over, yeah, here is cosine multiplied by cot, which is cot cosine. Yes, cot multiplied by cosine here. This must be squared. So here, cosine cot. Okay, cosine cot. So here 1 minus cosine square. Okay, so here it will be cosine square. So I multiply cosine over sine. In here, cot, I multiplied by cosine. It did me cosine square, cosine square over sine. Right? Clear now? Okay, so it's 1 minus cosine square, which equal actually to sine square. You remember this rule? Okay, over sine theta over sine theta. All this we are in the numerator, okay? Then we're going to take the denominator now. So sine theta square, sine square theta, we're going to kick the square with the denominator, which the whole here numerator is equal to sine. Okay. Okay, so now we are going to take it. And you see, we already got it from the previous question. Over 4 over sine theta, is right? And here is 1. So kick the sign with a sign which equal to 1 out of 4. And lastly, we did it. Okay, let's see the next. Oh, here in question number 10. I have a question. If y equal to x plus than x, find the equation of the normal. And the equation of the normal, you need the derivative. Here he play on something that's say that is the derivative or the dy over dx of ln x equal to 1 over x. Don't forget this. If you forget it, here you have a 5 mark just for this rule, you know. Dy over dx of ln x, the derivative of ln x equal to 1x, and that is a rule, okay? So look at here. Let's complete here. He wants you to find the equation of the normal of the curve. So first of all, we're going to get the derivative. So we're going to say that is the dy over dx will be equal to 2 plus 1 over x normally, okay? Okay, and here we're going to put the x for equal to 1. So it is 2 plus 1, which equal to 3. And here he wanted the normal. So the gradient of the normal will be equal to negative the flip, negative 1 over 3. To get the equation, we're going to say y minus 2 over x minus 1 equal to negative 1 over 3, which equal to, here, got to complete it. We're going to say which equal to the equation, simplify it. So here the equation will be 3y minus 6 equal to negative x plus 1. Bring the x here and the negative here, so the 3y plus x minus 7 equal to 0. Okay, so here we did it. 3y minus plus x minus 7, and we're getting 5 the mark. Let's see the next. He state the coordinate of the point where the normal intersects the x-axis. When it's intersect the normal intersect the x-axis, so the x will be equal to 0 because it intersects the x-axis. Okay, here we're going to say that we're going to make this, reset it just to make the y alone. So it will be equal to negative x plus 7 over 3 equal to 0, just to get when the normal, so the y here equal to 0. Okay, so we say this is negative x plus 7, and multiplying it by 3 by 3. Okay, let's solve it here. I'm going to say negative, the rule of the equation is negative x plus 7 over 3 equal to the y is 0. Okay, so by multiplying by 3 on both sides, we kick this and this still 0. Okay, this is 0 benefit plus 7. So we can move the x here, so the positive x equal to 7. So the coordinate of the intersection of the normal will be 7, 0. Let's see here. We did it. Let's see the next. Question 11, logarithm. So here, say step number 1 and 2 and 3. Let's get started. For number 1, we are going to change this to indices rule, which is equal to 3 to the power of what equal to 81. So let's say 3 times 3, 9 times 3, 27 times 3, which is 81. So 83 to the power of 4. So all of these are going to make it equal to 4. So now we have rule number 2. Here we're going to say that log base 2 x equal to 4. Then I'm going to change it to normal power. So 2 to the power of 4 equal to x. So 2 times 2 it's 4, times 2 it's 8, times 2 is 16. So the x now, let's say the last step, number 3, that's x equal to 16, and we did it. Let's see the next. Okay, here in this question, he asks you write log 2 1000 in term of 10, log 10. Okay, so here we have to know that is we can change log. Here we can change the log here. Say 1, 2, then 3. So number 1 here. Step number 1, we're going to use the rules that have the same base. Log base 10, 2 over log base 10, 1000. So now the 10 to the power 3 equal to 1000, is it right? So the base here is equal to number 3. So it will be, yeah, it's like this, yes. Let's see this, it will be like this. Yeah, we change it according to log 1000 up, log 1000 over log 2. So we say that log 1000 equal to 3 over log 2, log 2 base 10. Okay, so this is the final answer, which is 3 over log 2 base 10. And I did it. Let's see the next. Okay, here in question number 12, curve. Show that the line y equal to x plus 5 is a tangent of the curve y equal to x squared plus 6x plus 7. Okay, here you have two ways just to prove it. Okay, first way you have to equate the curve with the tangent, so 2x plus 5, and you get an equation of it equal to 2x squared plus 6x plus 7. And here you're going to make minus 5, solving normal equation. Okay, so here is 2 and minus 2x minus 2x minus 2x kick. Here you have positive 4x, positive 4x plus 2, and here 2x squared. All this will be equal to 0. So we have to prove that is the root of it has b squared minus 4ac. We have to prove it, show it that. So the b squared here is 16 minus 4 multiplied by 2 multiplied by 2, which equal to 0. So they have a point here. Or you can get the derivative here, get the solution of this equation, which is 2x squared plus 4x plus 2, and solve it normally, dividing by 2, dividing by 2, dividing by 2, or dividing by 2 will be x squared plus 2x, x squared plus 2x plus 1. You can solve it in 2-prac, which is x plus 1 multiplied by x plus 1, the same. So here we have one solution, x plus 1, and here x plus 1. So the x equal to negative 1. Back here to the original one, here the original curve, sorry, the original curve here, and we're going to say it here is -1, so 2 plus minus 6 equals 7, 2 minus 6 plus 7 will give us y equal to 3. Okay, 7 plus 2 is 9, minus 6 is 3. So here we can say it here we have a point and we get the gradient of it. So the gradient for this will be 4x plus 6, 6, which equal to the gradient at the point x equal to -1, so minus 4 plus 6 here equal to 2. So now we have to get the equation at this point. So x, y minus at this point, -1, 3. We have to get the equation from the point and gradient. So we say that is y minus 3 over x or plus 1 will be equal to 2. So we say that's 2x plus 2 equal to y minus 3. So we're going to flip it like this. So you can say plus 3 plus 3 plus 3 plus 3. So plus 3. So which gives us 2x plus 5 equal to y. And we prove it. Okay. Equal to y. Then get it here. So it's 2x plus 5 equal to y is tangent for the curve. Okay. Let's see the next. Okay, in this question he asked for a particular solution for the equation 6 of the derivative 6a to the power -2x at the point y equal 5 and x equals 0, or what we do, we're going to get the integration of it so we can get a solution. Let's see. Okay, so we're going to integrate this with the integration of this, so the integration of 6e minus 2x in terms of x. So we write it as it is, dividing by the derivative of the power which is -2, dividing by 2. So kick the 6 and the 6 dividing by 2, which is -3 e to the power -2 x. All that's plus c, don't forget. It's not limited integrate, it's a normal integrate, so all this is plus c. So now we are going to apply for the y 0.05. So kick this and put 0, so we kick. So it will be e to the power 0, which equal to 1. Multiply by here, -3. So -3 multiplied by 1 plus c, all that's equal to the y, which is equal to 5. So here is -3 plus 3. Take it. So the c now is equal to 8. So all what we do is writing the derivative, which is negative. This one is a c solution. So I would say y equal to -3e to x plus 8 and did it. Let's see the next. Okay, in this question, like the derivative, the radius of a sphere is increasing rate 0.2. Find the rate at which the volume of the sphere is increasing at the instant amount when the radius is 3. So we have a sphere as is increasing in a rate 0.2. Okay, give your answer in pi because it's an uncut paper. So let's get started. Here, as the first step, we are going to apply for the derivative of the volume of the sphere. Then I'm going to multiply it by 0.2. Okay, let's get started. So here it is 4 out of 3 to the power of 3. So I'm going to put the 3 down. So it is 4 pi. So we're going to not dy, we're going to d of the volume, derivative of the volume into to the time. Okay, so I kick the 3 here is multiplying by 3. So I kick the 3 here. So it's 4 pi and the r here is 3 multiplying by 3 all to the power of 2. So it equals to 9. Here is 4 multiplied by 9 pi, which equal to 36 pi. Then I'm going to multiply it by the rate, which is 0.2, which is 2 out of 10, which equal to 2 multiplied by 36, which is 72 over 10 pi. Then I'm going to simplify it, dividing by 2 with 36. So it's equal to 36 over 5 pi. Let's see if that's done. Yeah, not we did. Let's see the next. Okay, in this question, he gave you the term of a sequence or defined by a occurrence relation, which is a rule. It's a rule. I just want to confuse you. And the rule is say, for example, u2 will be equal to u1 times k. And he give you u1 is equal to 8, where k is a constant and then is more than 1. He's also given u2 plus u3, which we can say it is, we're going to first of all to get the u2, what's the value of u2, then we get the value of u3, then we're going to merge them to show that's this. Okay, first one is u2, so let's say that's u2 here. I'm going to apply just for the rule, n plus 1 will be equal to k multiplied by u1, and u1 equal to 8, so it's equal to 8. Okay, and u3 will be equal to k multiplied by u2, and u2 equal to 8k, so it will be k multiplied by 8k, which equal to 8k squared. 8 times 8, 8 times 1 is 8, and k times k is k squared. And now we're going to say that is the 8k, let's say the 8k squared plus the 8k is equal to 6 as he give it to you. Okay, we're going to kick minus 6 on both sides, minus 6. So 8k squared plus 8k minus 6 is equal to 0. And now we're going to divide the whole by 2 by 2 by 2. So it gives us 4k squared plus 4k minus 3 equal to 0, and we did it. Okay, so we already showed this. It's giving us find the value of k, so again, solve like a normal quadratic function. Here we have, we can say, here we have 2k, and 2k. Okay, and here we have 3, we can say 3 multiplied by 1, remain the inside number in positive 4, so here it will be 2 times 1, which is 2, and 3 times 2, which is 6, so we need to cancel 1 minus 1, so 6 minus 2, it will be equal to 4. So the k now have two solutions. So k equal to negative 3 out of 2, or k equal to half. Make sure that he don't give you any condition that the k is a constant and n more than 1. Here we have to, yes, find the value of k is given to the sum of infinity, because it will be, here we have sum of infinity, find the value of k, and given the sum of infinity, and you know this is between 0 and 1, so we have to kick this, so the solution for the k will be this one, so the k will be equal to half as final answer. I think we already did. Yes. Done. Let's see the next. Okay, in this question, he asks you to find the summation of the starting from the second term. Okay, so we are going to consider the binding 1 minus r is starting from the first term, start from the second term. So it is a over 1 minus r. So we're not going to take the a, I'm going to take the second term, dividing 1 minus r squared. Okay, because we have taken the second term. So it's equal to 4 over 1 minus 0.25 over 1 over 4, or 1 over 2 squared, 1 over 2 squared, which equal to 4 over 1 minus 1 over 4, which equal to 4 over 3 quarters, which means 4 divided 3 out of 4, which equal to 4 multiply 4 over 3, which equal to 16 out of 3, and we did it. Let's see the next. Okay, here is the last question 15, which almost the hardest. The last 5 questions, you know the exam is it hard. If you see the last 5 questions, if they are hard, so the exam is hard. If they are easy, so the exam is easy. But this area under the curve, which is very easy. Let's see the diagram shows the curve y equals 4 sine 2x. 4x is between pi. The horizontal line, that is the horizontal y equal k. If k is not equal, is a tangent to the curve at the point P. Okay, write down the coordinate of x at P. For sure, here is pi. You see, this is pi. Okay, and this will be here half pi over 2. And for this, it's halfway. It's pi over 4, or it's a quarter half. All right, okay. So it is pi over 4. See the value of k. Okay, so we're going to substitute here the 2x, the x with pi over 4 and solving normal equation. Okay, so I'm going to say that is here we have the 4 multiplied by sine 2 multiplying by pi over 4. So it's equal to dividing by 4, dividing by 2, it's 1. So pi over 2, which is sine 90, and here sine 90 or sine pi over 2, which equal to 1. So it is 4, it will be equal to 4 multiplying by 1. So it's equal to 4. Let's see the next. Here, we're going to find the derivative. You see that's in your formula sheet, you have the integration rules for sine and cosine. You'll find it in the formula sheet. For sure, sine is negative cosine, so it is negative 4 cosine 2x plus c. Remember here dividing by the coefficient of x, which is 2, so it's dividing by 2 equal to negative 2 cosine 2x plus c, and we did it. Let's go next here. For sure it will be completed with the shaded area, the area under the curve. So we already get the integrate here, we get the integrate, and we did it, that's all. So it is. So let's see the next. As he shaded, he must ask for the area of the under the, yeah, for the shaded area enclosed by the blah blah blah. So as you see this, we have a line, and beside the line there is a shaded area. So it is will be line minus curve, the integral of line minus curve, and this curve is enclosed by 0, which is the y-axis here. The x is 0, and pi over 4. So let's get started. Oh, I need the integration. Yes, that is the integration. Just we're going to write it here because we're going to add the line. Okay, so here we have the line, which is 4. We're going to get the integral of 4 minus not minus, we're going to write it as a 4 sine. Okay, so it's minus 4 sine 2x. So I'm going to get it from the beginning. So from the beginning it was 4x. Another 4x, remember that we have a limited integration between 0 and pi over 4 minus 4 sine not 4 minus 2, we get it minus 2. Yes, minus negative 2. Okay, sine 2x. Okay, and again we are going to get it. Here we have minus 2 sine 2x. I wrote it 2 times, just we have a limited here of between pi over 4 and 0. Okay, so first of all we're going to change this, the 4x, it will be like this here. So here it will be equal to 4 multiplied by pi over 4. I will make the line first, then I will make the curve, then I will subtract them, okay? Because we get the derivative of the line, then of the curve here, and then I'll subtract them. Okay, so here is a line, and here is a curve. Okay, for sure the line we're going to get it, that is, it's 4 divided by 4, which is equal to pi. If we substitute it, the x here with 0, so it gives us minus 0, so it's equal, the line will be equal to pi. Okay, then we're going to subtract here the, so here we have minus 2 sine, let's see, that's 2 multiplied by pi over 4, which is pi over 2, so it is sine 90, sine pi over 2, which equal to 0. Pi over 2 equal to 0 multiplied by what? It's equal to 0. So here is 0 minus sine 0 here is equal to 1. Sine 0. We have a limited between 4 and we get it to 4. And we're going to get the 0. So sine 0 here equal to 1 multiplied by negative 2. So here it will be equal to minus 2 multiplied by. So here the 4, we get it pi. So the area will be pi over the line minus the curve, which is minus 2. And we did it.